A lot of college is about individual success, but in the real world, people often work in a team. With so many people on campus and within the College of Engineering, how do you get them to work together? The answer: group projects. The Engineering Fundamentals Department has long utilized this tool to give students a fun way to learn. Whether it be building a musical instrument and playing Rocky Top or building a Rube Goldberg machine, the object is to learn.
What else is it going to see? My robot sitting all the way back there on my chair. A whole lot of other stuff too, okay? So we can use the IamCrop command to crop our image down from all of this stuff out here to where it can just see my red ball. Okay? So that's going to be one of the main commands that you might want to use, IamCrop. So that way you can make sure that your robot is focusing on one single area.
But what about a class like Engineering Fundamentals 230, which involves teaching the programming language MATLAB? Now, if you've ever tried to read a programming textbook, you know that programming information can be a very dull subject. So how do you make up for that? The solution is interactive projects involving programming. Computer science is an abstract concept for many, and the wide array of possibilities far exceeds the class. The Engineering Fundamentals Department has invested in bringing real-life programming applications to students. This means more hands-on work assigned in class, where small groups can explore the technology together. These groups are carefully picked with students of varying skill levels and personalities so that everyone gets an equal chance to learn. Since the beginning of this practice, the response from students has been overwhelmingly positive. Their participation and interest in this class continues to increase with more diverse projects. Students walking out of this classroom are taking away more than just programming knowledge. They are better teammates and leaders.
My name is Grayson Hawkins. I'm a student at the University of Tennessee, Knoxville. I took this class, Engineering Fundamentals 230, and I built a project. Our project is called the BEAR. That stands for Bacteria, Environment, and Analyzer. Essentially, it consists of a microcontroller that controls and monitors the temperature of this insulated cube. There's a heating element in here. And also, there's an LED light and a photovoltaic sensor on the opposite side. Open this up. Inside you can see a heating element. This is just nichrome wire wrapped around a wooden dowel. The nichrome wire is set to burn at about 120, 130 degrees. Styrofoam's not gonna melt. Even this hot glue on it won't melt. There's a place for the sample, a bacterial sample in a test tube to fit in the center. There's really not that much volume, so I think it's 3 volts that's actually going into the heating element. So very, very small power application. Essentially, when you put a test tube down into this insulated chamber, as the bacteria grows, it's going to get denser and denser, so when this LED light shines through, the photovoltaic sensor is actually going to register less and less light as time goes on. You don't really learn until you apply it to something like this. And really, we were given so much freedom, and as a mechanical engineer, I got to design an insulated chamber. I worked closely with a chemical engineer and another mechanical engineer, and it was just overall a really good experience.
The University of Tennessee, a place that allows innovation in the classroom today to promote the successful alumni of tomorrow.